Good afternoon, ladies and gentlemen. It's always customary at Autodesk to start with one of those videos to show everybody what sort of software it is that Autodesk provides. Now, my name's Karsten Hojberg, and I've got one of the greatest jobs ever. I get to give free software out to people. I give £100,000 worth of software to cleantech startups and entrepreneurs just because they're in the cleantech space. And we do that because we think it's very, very important that this sector gets pushed forward. Now, we also do that because one, we don't want the investors to have to pay for it. We don't want to have the SMEs and the entrepreneurs to have to pay for it. And we want the products out to market faster. And we certainly don't want government grants used on software either. So that's very, very important to us. I've given away probably in the last 30 days over, let's say, £100 million worth of software. So if there's anybody in the room that's doing some designs that hasn't spoken to me yet, please come to me after. Now, the reason we do this is because at Autodesk, we are absolutely focused on a better world. Better for people, better for the planet, better for the climate, just generally better. So for us at Autodesk, we've been around for 30 years as a software company, but we're more than that. We're people that obviously develop our software. We have partners that on-sell our software and work with customers. We have customers who are doing the sort of work that you've seen in the video there. So for us, it's about a network of people who are helping to imagine, design, and create a better world. Now, we all know that right now, we've got to realise what that better world looks like. So by 2050, we're going to have 9 billion people living in the world. And this is our vision for what we want to do. They need to live well and within the means of the planet. So that's why it's absolutely imperative that we have, on our side of the table, a sustainability strategy that drives that thinking. Now, we know that to be able to get to there, we've got some epic challenges that we've got to face, overcome, I should say. None of them are new to anybody in this room. You know, climate, health, urbanisation, believe it or not, water. Well, it's a bit funny being here in the UK at the moment. But, you know, last week I was in San Francisco and they've got a drought. And you can probably tell from my accent, if not from my name, I spent a lot of time in Australia. And when you're in a desert country and there's a drought on there and the newspapers every day start to report that the dams are at 20% of capacity, you know that you have to start thinking differently about what it is that you do with infrastructure, what it is you do about resources, and what it is you do about how to make these challenges go. We're also seeing a lot of changes in the way people react and work, technology changes, generational changes, technology changes in the way things are being fabricated and built. I know myself, I have 3 daughters. You know, I used to etch a sketch in a doodle pad, right? They're using iPads and doing it all digitally and storing themselves on Dropbox and whatever else. Things are changing. Now, this is the thumbs up panda. This is to give you an idea that we serve other industries other than manufacturing growth. But across all of the industries we serve, whether that's media entertainment, whether it's architecture, construction, or the manufacturing environment, or even infrastructure, we're seeing some very clear trends emerging and some interesting statistics that are driving our thinking. So I just want to go through that today. The first of those is 2 billion people are going to be moving to urban areas by 2050. You know, and that means they're going to move into urban centres, not like Scunthorpe or Shropshire or that sort of size, or even Copenhagen or Sydney. There's going to be new Londons. There's going to be new Tokyos. There's going to be new Cairos. 20 million people in one spot. And the challenges that we face being able to develop, smart cities and smart grids that'll be able to overcome that. Suspend your disbelief. I know that's hard to imagine right now, but there will be a water supply gap by 2050 of up to 40%, which will cause enormous problems around the world. 34% of the world's population is online. I don't know how anybody doesn't be online now, so I don't know what the other 64% are doing. They're obviously not buying their movie tickets online. That was meant to be funny, just so you know. No more jokes. Robert was right. He said, don't try your jokes. And 21% of people have a smartphone. 21. Does anybody know anyone who doesn't have a smartphone? So there's obviously big markets out there for people that haven't got a phone yet. So that, coupled with how we're developing our software, is driving our thinking. We're seeing some very specific trends. The first is mobile computing. Okay, I can remember, I'm old enough to remember when people, had 1 or 2 computers in the office and that was it. Now we're moving away from being stuck at a desk. People are buying tablets, not even laptops anymore. We're all getting smartphones. And what that's doing, it's driving a difference in the way we want to work. It's driving a difference in the locations that we work. And it's driving a difference in what we can do. If you think about the drawing diagrams, which is the world we live in engineering, I mean, they're heavy, big documents, and you can't take a drawing office to the site where you're working at something. But now you can take your iPad and just draw out the documents that you want. It's an enormous change in the way you think, and it drives a lot of creativity when you're on site rather than in a drawing office. The other is infinite computing. We've been looking at computer technology all wrong. Absolutely. We've been looking at computer technology like it's a scarce resource. And the truth is, it just isn't. With the cloud software, access to Google servers and all of that process, we no longer have to worry about the capacity of our computers anymore to drive what it is that we want to do. And if you think about the smartphone that only 21% of the people in the world have, in this phone we've got up to 30,000 times more powerful software or computing capability than was in the first space shuttle. And this gives me access to more computing power than was around, that even existed 4 years ago. It's an enormous driver of the way that we think about design. And just to give a practical example, that's not a picture of me. You might remember that's, I think, another Australian, if I'm not incorrect, from the movie Avatar. Now, that's quite a difficult movie to make because it was all done with computer rendering and that whole process. And you can see a single frame of film, one computer, 72 hours. Now, currently the thinking is you do 24 frames a second. So that's a lot. The 2 Hobbit movies that just came out, they're 48 frames a second. So we're starting to get really deep and rich computer rendering that requires a lot of power to run. So the frame is, do you do one computer for 259,200 seconds, or do you do 2,500, well, whatever the number is, for 1 second? The result is, for the same cost, you get that result much more quickly. Now, that's great in the movies, okay, and we win a lot of Oscars for computer-generated graphics. But if you think about some of the presentations that we saw today, tidal energy, wind energy, even combustion engines or water flow through pipes, if we're talking about doing anaerobic digestion, it's all about fluid flow. So if you can do, one computer does a computation maybe 30 times, you can now do 30,000 in the same amount of time or shorter. And what that means is not that you get the result faster, is that you can iterate more often, you can take more design risks, and hopefully that drives more innovation. The third trend, which is absolutely fascinating to me, I've been in manufacturing for a long time, and this notion of digital fabrication, 3D printing, additive manufacturing, whatever buzzword you put on it now, is just absolutely incredible. So we're seeing things like running shoes being printed, fashion being printed, we're seeing cars being printed, that whole process. Body parts like titanium jaws all being 3D printed. But there's 2 very important trends that are coming out of that just recently. The first is we're starting to put together additive and subtractive. So now we build up layer on layer to get a particular device, and then in the same machine we do some CNC milling, and we start to put holes in it and take stuff away, so that we're getting much, much faster time to market, and we're getting these design ideas much more cost effectively out to what we want to do. The next is probably exciting because I'm a software guy, but previously what was happening is that to be able to do one of these machines, if you wanted to change the material that you were printing in, then you had to change the material that was going in. Not anymore. We now have the ability to be able to mix environments with a software update. So if you want to move from steel to copper, it's a software update rather than a change to the machine. And what that means is factories of the future and people who own these machines don't have to keep swapping them out. Okay? They just update the software and they start to turn these things out much, much more quickly. So that's all great, but what does that mean for us? For us, it's all about design. So, design's about systematically changing the world you want to live in. It's about shaping that, and design is becoming much, much more important. And even if we thought about what happened to what we saw today in the presentations, wave energy hasn't changed. I'm presuming, I'm no fusion expert, but I'm presuming fusion hasn't changed over the last 40 years. But technological advances, coupled with people's drive to want to do something better, has driven that innovation. And for us, that's why it's very, very important to link design to that process. So, design, particularly as it relates to Cleantech. There's a few very definitive areas that we want to talk about. We have cloud technology now. We can design on our iPads. As long as we're connected to the internet, we can start sharing information. It does mean that I can have an engineer in Manchester, I can have a designer in Copenhagen, and I can have an engineer in Australia, and they're all working on the same document seamlessly in the same time without the problems that you used to have even 5 years ago. We can design differently. As I talked about, the computational power now to decide whether or not the plastic is too thin or too thick, too costly, not too costly, or change the sort of shape or feel that you want to do something. Because of the way that computers are structured with infinite computing, you can do that much more quickly, and we can iterate much, much more quickly and get, hopefully better designs, thinner, maybe more sustainable, better material, and start looking at things with a deeper design process that is actually going to help us solve some of those epic challenges we talked about before. Design anything, anywhere, anytime. So we're now having 3D design software on the cloud. Okay, so you don't even need a laptop to drive the machine anymore. We've just brought out a 3D modelling tool called Fusion 360. You can log on now on the Wi-Fi and start design something, send it to somebody else, put it in a gallery, and then send it to a 3D printing shop to actually have it made. Amazing advances in technology. And the last one is probably more exciting for me. I think looking around the room, most people are probably the same age cohort as me, other than a few young ladies and men I see around. But generally speaking, we think differently. We've been taught to design differently than our 13-year-olds and our 12-year-olds. They've grown up with technology to share, grown up to technology to stretch and bend and shape and move things around that we just weren't even thinking was possible 20 years ago. So we need to embrace that new level of designer, because it's those people that are going to drive the interaction to the environment. So let's talk very specifically about our Cleantech strategy as I close off, and I just wanted to go through a few Cleantech companies, sort of like the ones I've been presenting here today, but maybe next year I'll present those ones up here. But our Cleantech strategy is to be able to provide this grant of software to people like yourselves and people investing like yourselves that are investing in, so that we can get these products out to market faster. The first one of those is really exciting. It's called, by Uncharted Play, called a device called Socket. Now, it looks like a football, but it was made in America, so they called it a soccer ball, and then socket, because socket, electricity, and anyway, if we did it here, it would be called Foot It or something, and probably wouldn't be as sort of punchy and dynamic. But the idea of it is that the kids muck around with it, kick the ball, and it generates some energy, it stores it, and then they can use that to power lighting for schools or electricity that's certainly off the grid. Very inspirational, and these people are getting a lot of play. Love this one too, particularly around we heard a bit about wood combustion. The BioLite stove takes burning combustion and turns it into electricity so you can charge your iPhone, which personally I think is really handy because they run out in like 20 seconds. Anybody even notice that? Frustrating. We'll give a BioLite to everybody who's here. And one of the really important things about there is 3 billion people who cook on open fires. 3 billion. Okay, and they're saying that there's 4 million premature deaths from the output of the smoke and the bad stuff that gets let out when they cook. This particular device not only charges electricity off the grid, but it also reduces the burn of the material by 50%, and it cuts the emission down by 95%, hopefully saving lives as well as giving people electricity. So very inspirational crew. Now a little bit closer to home, smart hydropower. The gentleman out of Germany, the gentleman who did this, was looking at the Amazon in Peru, and again, completely off-grid, very difficult to get diesel engines in there, and the fuel and the fumes and whatever. So came up with this idea. That's one of our designed in our application product design suite. And the idea is that you put that in the river, you don't need to dam the river, you don't need any gradient, and it will self-run and just be easy to maintain. A very clever innovation. CAB, which is a UK-based company, anaerobic digestion, to be able to take all the smelly stuff from the farm and the biomass and convert that into fertiliser as well as electricity. Again, that's the CAD model, and that's the real one. You can see that there, part of our program. Again, just a small startup. And the last I'll talk about before I finish up is Enval, another UK company. This is about a particular chemical process for recycling of plastics that wasn't necessarily able to be done effectively or at all before, as well as aluminium laminate. And again, the CAD drawing, and then there's the real machine there. So that's it for me. I've probably run a little bit over time, sorry Robert, but I did want to show through some of those customers, and I do hope that hopefully next year when I'm up here presenting, I'll have 4 or 5 of the presenters that we heard here today talking about the software. Thank you very much.